principle. Okay. That's good. Right. Okay. Right. Okay. Here, right. You right? I'm showing you the basis functions having 1 at the given node, and then surrounding node it has 0, and in between it has some heights, right? So I'm showing you the example, and these things are basis functions that we need to create, and I will let you know how to do these things today. And next time we'll handle general case theoretically, but we don't really program general case, but at least knowing general case is very important, and a little bit of consideration about automation generation too. But today we will focus on basis functions like this. In other words, these are basis functions. For instance, like 0.7 and then 0.3, right? So x coordinate is 0.4, y coordinate 0.7, then it has height 1, and the other place it has 0. These are basis functions, and we will analyze these things, and then consider the idea of really implementing these things. So how to implement this kind of thing is the case. Of course, someone already implemented the stuff and emailed me about the difficulties, because he said he used a lot of if conditions, a lot of ifs. But I think I used ifs, but I used more functions. I used functions more than ifs. But in any case, these are boundary things. So I numbered these in this order. Interior is handled using user array, and then exterior is handled following the boundary. These are the things that I did, and we will study about these things, and then learn about the method of implementing these things. And next time, we will learn about general theory, not just limited to the cases that we covered, but a little bit more general case. And then, after the theory, we will learn about the automation generation idea, and then real implementation difficulties that you may encounter during the week. But in any case, let's consider the basis functions. As I mentioned, you saw enough, right? You saw more than enough about the basis functions, but assume that you have basis function. I will divide a rectangle by 2 subintervals in the x direction, and for instance, 2 subintervals in the y direction, or maybe let's change it to 3 subintervals in the y direction. In other words, we have 2 subintervals in the x direction, 3 subintervals in the y direction, then you have total 6 rectangles, and then 12 triangles. Then I will show you the 1 times phi1 shape. 1 times, this is one coefficient, this is the index. So 1 times phi1 function when we subdivide it this way. So I will describe the situation. We have a domain, then we divide x coordinate by 2, and then we divide this by 3. So we have this situation. Then we have, under our assumption, we are using just triangles like this. then we have total 12 triangles. Then I number this way. I number interior first. This is the first node, right? And then second node, and then third one, fourth one, fifth one. I number this way. This isn't the only way, so later, like next time, I will let you know about the automation generation idea and the numbering this kind of thing. So assume that we order this way. This isn't the only way, but assume that we follow this idea. Then what is the shape of phi1 function? So let's see phi1 function. First of all, I will run it and then show you. So this is the phi1 function. So let's completely analyze this phi1 function. Phi1 function has height 1 at the given node, right? At the given node, 1/2, and then 1/3, it has 1. And at other nodes, it's 0. And then in between, it has, like, if you focus on this triangle, it is simple plane, right? Plane. In this also plane. So let's look at this from the top. If you look at this from the top, it looks like this. So take a look. This is the first triangle, right? Second triangle, third one, and then fourth one, and so on, right? So there are 12 triangles, and then it looks like this. And then you can imagine the height using colors. Highest, and then lowest, right? And then zeros. So we are creating this thing. Any questions about the shape? So let's rotate this thing to look at the shape. Excuse me? Triangles, right? 12. Right. For one street, we have 4 triangles. 1, 2, 3, 4 triangles. Okay. Even including outside. Oh, involved triangles are 6, right? Involved triangles are 6. 1, 2, right. So total triangles are 12, but involved triangles are 1, 2, 3, 4, 5, 6. Total 6 triangles are involved because of our design. But this isn't the only way. In fact, my program can handle any triangle. But let's not worry about any triangle. But let's look at the shape first. Once you see the shape, you will get better idea. So let's rotate this thing to look at the shape. It looks like this, right? So it looks like this. It is not exactly symmetric, right? It is asymmetric, but looks like a pyramid, right? It's like this, right? So these are basis functions. I mentioned these things before, but you really see the shapes. So if you have a question up to this point, ask me. So it has 1 here, right? Because this is the first node, and second node, and then third, fourth, fifth, sixth, and so on. So let's look at the basis function at the second node. But if you want to return back, you can ask me anytime. So let's look at the triangle at the second node. Then this is the triangle at the second node. Of course, it is obvious, right? This is obvious. Second node, right? So 0.5, right? 0.5, and then 2/3, right? 2/3. It has 1, and then other, it has 0. So let's rotate it. So this is the second node. Any questions? And then third node might be the different one because it handles the corner, right? I will handle phi 1 times phi 3. 1 times phi 3 looks like this. Of course, on homework 8, you don't have to really sketch these things. You just implement the function. In other words, I will write the homework. On your homework, you need to do these things. Phi ij, for instance, P 5, 6, and then I use, for instance, 0.5, 0.6. Then your answer should be 1, right? or something like this. Or it may not be 1, but something, right? This is all I want. So homework has nothing to do with any plotting. Just giving this kind of value is the task, right? Giving this kind of homework 8 is not sketching anything, just implementing this kind of thing for any number here, ij, any number, any ij combination, and any xy position. Once you give this kind of things, then it determines the position, right? 5, 6 position, right? 5, 6 position, and then these values are given. Then it could be some number. Depending on your assignment, it may change, but roughly 1 might be the result. But in any case, let's browse this thing. So if you look at this thing, it has node here, right? So first node, second node, and then third, fourth, fifth, sixth, and so on, right? So this is the one. And then it has 1 here. It has 0 here, 0 here, 0. Surrounding node, it has 0. And then we are sketching this thing. So this is the third node having corner here. And then next thing is let's return back to homework to exactly guess the value. So let's go to homework part. So homework A says define a function. So these are conditions. 1, 2, 3, 4 are conditions. And all you need to do is the implementation of function like this, right? This ij varies between 0 and 10. So roughly, if I is 5, then it is 5 over 10, right? 0.5. If j is 6, then it is 6 over 10, 0.6, right? So having that kind of, this kind of value, right? So in other words, we don't have to worry about this. It is 1, right, by definition. This is the definition, right? Do you follow me? And or at all other nodes, it should have 0, right? And then something in between is the major concern. For instance, 5, 6, 0.55, and then 0.64, right? These kind of things may not be 0 or 1. Something in between, right? Some height. So let's return back to the sketch of these things, graph of this thing. So this thing. So this is the shape of the, so I'm showing you the height, right? Height is 1 here, right? And then height is 0 at surrounding nodes. And then in between, for instance, like 0.3, then we can check the height, right? At 0.3, what could be the height? At 0.3, it could be like something here, something around here, right? Something around here. So we can check the height. Depending on position, we have different heights. And the harder part is not this kind of side, but this kind of side might be harder, right? This kind, or this kind of side might be hard. These two sides might. Let's look at another case that is fourth node, right? So let's check it. It is the first node, second node, and then third node, fourth node, right? So let's look at case. So as you can see, it has this kind of, it is not symmetric, as you can see, because of our design. Our design is not symmetric. So it has 1 here, and then surrounding node 0. But it is not symmetric, because when you break up the domain, we didn't break up this way. We break up just uniform way, right? Uniform pattern. So it is not exactly symmetric, but it looks like this. So let's look at the shape. It has height 1 at the node, right? Height 1 at the node, right? Height 1 at the node, and then at surrounding points it had other heights. Of course, if I were asked to really sketch it, I might have a hard time. Computer did it. So I didn't really have to sketch these things at all. Just computer generated these things. So if you have a question about basis functions, shapes, ask me. If you don't, then I will let you know about other important aspects. But you may wonder, oh, everything here looks very sharp. So I will return back to the case like this. How can you combine these things to create smooth surface? Everything looks very sharp, but you did it with one-dimensional case, right? One-dimensional basis function looked very sharp, right? But by combining these things, you could create nice curve. Very similar here. With these sharp things, you can really create very nice surface. So to prove this point, I will do the linear combination of these things. So I will do the linear combination of these things. So let's do it. So because if I divide it, it will be too smooth. So I will just divide roughly. 2, right? 2 units, and then 2 subintervals in x direction, 2 subintervals in the y direction. If I really sketch it, then only this thing, right? Roughly this is it. So I break up this way, and then these are all triangles, so I should use this uniform pattern. Then how many basis functions are there? How many? 9, right? So I number it this way. 1, and then 2, 3, 4, 5, 6, 7, 8, 9, right? Of course, this isn't the only way, but it's a convenient way. So let's do it. Of course, it's possible to order the nodes this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's possible, right? It's possible. So let's do it. And I will really create something, right? So this is the first position and second position. So I will do phi1 plus phi2. I will write the coefficient later. And then phi3 and so, right? So I will write this kind of linear combination. So you pick these coefficients. You pick these coefficients. I want you to choose some number between 0 and 3. 0 and 3, any real number is okay. I want you to pick these coefficients. So what is your first coefficient? 2. What is your second coefficient? 2.7, right? What is your third coefficient? 1.5, right? And then I will just randomly write the stuff. So let's do it. Then 2 and so for the first thing, coefficient is 2. For the second thing, 2.7. Did I use 2.7? Right. 2.7, and then second node, and then third node, 1.5, and then third node, and then fourth node, any number, right? 1.2, and then fourth node. This is just my implementation. You may implement differently. And then 3.1, and then fifth node, and then 7 is too large. 1.7, 6. As you can see, I just broke up the interval using just 2 subintervals, right, in each direction. But with this, you will see very smooth-looking result, even though individual bases look very, very sharp, right? I made a mistake. And then any number is okay. 7, 0.2, 1, 2, 3, and then 8, and then finally 0.5, 0.6, and then 8. So do you understand what I did? I create a linear combination of the basis one. That's all we worry about, right? This is all we worry about. We determine this coefficient and assemble. Because phi determination has nothing to do with any differential equation. Phi is determined once we determine the node positions, right? Phi is determined automatically, no matter what. Once you determine the node positions, phi is determined. So the only thing that changes because of the differential equation is the vector c, right? Vector c, the coefficient vector. So this is what I did. And then let's look at the result. Did I miss any? So let's look at the surface. I should have used different function. I guess it is not the one, basis one. Because to show you the nice basis, I limit the linear combination. So this is the shape. So as you can see, first of all, I will show you the domain. We are handling the problem on this domain, right? We are handling the problem on this domain. And then take a look. First node should have what? What height? 2. So let's check whether it has 2 or not. How can you really see the... Oh, first node is not the corner one. The center one is the first node, right? First node. So let's check whether it has 2 or not. So does it have 2? Can you follow it? It has height 2. What about the second node? Second node has height what? 2.7. What about the third node? 1.5, right? Do you see 1.5? How can you see 1.5? This way, right? Almost 1 point, you can see 1.5, right? And the next node has what? After 1.5? I just typed some. Let's go back to the program. It is 1.1, right? 1.1, 3.1, 1.7. So let's check these numbers. 1.1, right? Here it has 1.1, right? Here it has 1.1. And then the next node has about what height? 3.1, right? And as you can see, each node is represented this way. This is nothing but a linear combination. And then even with very arbitrary and stuffs, once you look at the surface, it looks nice, right? It doesn't look that sharp. So using these things, you can solve a differential equation, and I will show you one example. FEM, and then I'll assume that we divide it by like 5 and 2. 3 and 6, right? So we break up the X domain by 3 subuniverse, break up the Y domain with 6, and sketch it. And then I'm solving different differential equation because our one is very flat. It is not very dramatic, so I solve the different. So I'm just showing you the usage of this base. In some sense, basis creation is almost everything. Other stuff is very minimal. So today I will cover this basis part completely, and next time with general theory and automation generation idea, and then the basis function usage to solve differential. So this is the differential equation I solved, and then as you can see, I subdivided X domain by 3 subuniverse, right? And I divided the Y domain using 6 subuniverse. So total 3 times 6, and then triangle means having, right, doubling the number of triangles. So it is what? 36, right? 36 triangles were used to create this kind of surface. Of course, if you have a project like creating some kind of surface like airplane surface or car surface, then we may subdivide more, like 1,000 by 1,000, and then do these things. So take a look and then check whether you completely follow the idea or not. As you can see, it doesn't look like the combination of those cone-style things, right? Combination of cone-style things made these things. So it is not. But you already experienced these things, right? Using sharp things, you create a curve when you solve FEM on one-dimensional case. So this is it. And then after this, I will go back to the idea of implementing these things. But if you have a question, ask me. Then let's do it. Of course, this is too slow, right? So I save time by removing rendering part. Rendering meaning what? Rendering means we are really representing these things using graphics. But if we remove the rendering part, it will be way faster. It will run way faster. Of course, I solved a different one with this idea. So it's our one, our stuff. So without rendering, we can run it very fast. So like even 30 by, that's not 10 by 16. It's pretty large, right? Without rendering, it's way faster. So you don't have to really create the rendering part. But once you create a basis function, you may want to really sketch it. Because you already have a function, then you just plot it, then you just show everything. But I don't require you to do this, the rendering part or graphing part of the, homework 8. So before going any further, if you have a question or if you want to look at any graphics or anything, then ask me, then I will show you. Do you want to see any graphics or something that you have questions? So you completely saw the basis function, individual basis functions, and then saw the solving part. Of course, that linkage will be mentioned next time. Today we will focus on the implementation, because these are the things you need to create. I will not show everything. I will only show you one case that I mentioned last time. I mentioned about triangle determination, right? So how to program this kind of determination function is shown here. Of course, you might see that this isn't very efficient, but I just programmed this in and explain individual steps. Can I increase the size of font here? Can I make bigger? How can I do it? Is there any font enlargement thing? You never saw, right?
I'm sure there is. Edit preferences.
Edit preference. Where is the preference?
Options, something like
But because all of you can see, just let's analyze that. So this is usually when you create something, people do not know how to use it. So it's good to add this kind of comment upstairs or downstairs, right? Somewhere nice, but I just wrote down idea. So what I did was this one. Inside the triangle function is created this way. This is the position, right? This is the position. And these things form a triangle, right? These things form a triangle. Do you follow me? So I just input this way. The position that you want to determine and triangle coordinates, right? So 2, 3, 2, 2, 5, 5, 5, 7, right? These are coordinates. Then when you program, you should be careful because you just sometimes do not follow the restriction. It should be a triangle. But sometimes people just type, for instance, 1, 1, 2, 2, 3, 3 in the triangle position. Then is it a triangle or not? 1, 1, 2, 2, 3, 3. Is it a triangle or not? It's a line. Then there could be some kind of strange malfunction or something that is very hard to debug. So to prevent this kind of problem, you should check that kind of condition on your own, right? Check whether it's a triangle or not. So I added this thing. In other words, I mentioned about the side last time, right? I used the vectors to create the side, and this determines the side. Is left side or right or plus side or minus side, right? So it's plus side or minus side of the vector product, right? Vector cross product. But if it's neither, then it is 0, right? In other words, if this happens, then the 3 point cannot form a triangle. In other words, if something happens, then even though some conditions are satisfied, I want to return 0, right? I want to return 0. So this part checks whether it's a triangle or not. Of course, you may program very efficiently, but at least I implemented this part. So 3 points are checked, whether they form a triangle or not. Any questions up to this point? And now, because of the technical reason, because I want to form a vector from first point to the second point to the third point, and then third point to the first point, I copy first point and in P4. This way I just subtract Pi minus 1, right? Or Pi plus 1 minus. So this way I copied this thing, right? So first one becomes the first one too. First one didn't exist in the input, but now it becomes. So we now have P vector from the input plus copy, right? From the input we have 3 coordinates, right? And then from the copy we have 1 more. So we have 4 pairs, right? We have 4 pairs. Then now we assume that the point is in. In other words, this point is inside, this point is inside the triangle. So I just assume this. And then once it is violated, I will return 0. In other words, in is 1, out is 0. Of course, in other languages such as C++, you can use true or false. Real Boolean is possible, but we don't have to worry about this kind of thing. Just using 0 and 1, we can do it. What is the advantage of this thing? If you use 0 for the false and then 1 for the truth, then what is the advantage? We can directly multiply this result to some value. In other words, if it's in, then it is 1. Then we can use it. If it's 0, then it doesn't affect anything. But you can design anyway. This is my design. Now, as I mentioned before, from this point on, all we need to do is checking the side, right? Just this number came from the vector product, right? Vector product that I mentioned, right? Then we can do the right thumb rule to check the direction. Initially, when we checked this way. From P1 to P2, we create, using these 2 vectors, right? Using these 2 vectors, I will explain this thing on notes. Initially, what we did was this one. We had a triangle, P1, and then P2, and then P3. So this is what I did. So we initially checked this thing. We initially checked P1, P2 vector, and then P2, P3 vector, right? And then we wanted to check whether the point here satisfy this thing. In other words, this vector, so let's say 1 vector multiplied by question vector, right? 1 vector cross product question vector is up or down. We wanted to check this thing. Do you follow me? And then afterwards, we want to check 2 vector and then question vector product up or down, and then this vector, and then, right? So this is what we wanted to do. But to check whether it's a triangle or not, I used this point as question mark. So in the first setting, I checked it. So the first line that I used was, in fact, this line. This thing replaced by the third point, right? replaced by the third point like this, right? Instead of using arbitrary x, y, I use a third point to check the direction. Because I checked the direction, this x position and the third position should be on the same side of this line, right? Do you follow me or not? Because when I initially checked whether it's a triangle or not, I checked whether the third point is on the left-hand side or right-hand side. If it's on the left-hand side, it's upward, right? If it's on the right-hand side, it's downward because of the right thumb rule. So I stored this side direction of the third point. Any inner point should have the same direction. Do you follow me? So because of this reason, only thing that I need to do is calculate S and then S direction that I decide, right? S direction is decided here, and then current S direction is multiplied together, and then if they are opposite, then it cannot be inside the triangle. So this is the program that I designed, and then in any language you can program it. In fact, I programmed these things in like 1980 something using Fortran, and then when I worked at a company, I used C to program. Now I use MATLAB. So using any language, you can do this. So please browse the idea, and if you have questions, ask me. This is the only one that I show you fully. Other things, I just wave hands and explain. So please browse the idea and let me know whether there is any difficulty or not. So side is checked by using the third point, because third point and interior point should have the same side, right? Because once you have a line, then third point and the interior point should be on the same side, right? So this is the triangle checking. Then, now it's time to design. As I mentioned, there is no textbook algorithm scheme or design scheme. Individual people should design these things. For instance, company A may design this way, B might design differently. So this is my design. It has nothing to do with general one or your one. So we have a triangle case. Of course, next time I will mention about general shape. Assume that you have a general shape, then how to, for instance, plot nodes, and then once nodes are determined, then my program will automatically run and then check all the necessary things. But in any case, how to do these kind of things, not in just one dimension, in three-dimensional space, instead of triangles, we should use tetrahedron, right? Using tetrahedron. This is a huge part in computer science because representing some kind of shape. Assume that you made some kind of product. You made a cell phone. Do you want to really make those kind of cell phone using some kind of material or use program? Assume that you use program, then how can you really represent? So you use these kind of things to really to render your stuffs. But in any case, this is too much to cover. So let's not worry about very general case, just simple case. So initially, this is what we do. This is, assume that we break up this. Intentionally, I will break up by just two sub-universe here, and then three sub-universe in this direction, intentionally. In other words, I will call M equal to 2, because in this direction you have two sub-universe, right? And then N equal to 3. In this direction you have three sub-universe. Do you follow me? Then we have, I will use two index notation instead of, two indices notation instead of like order that I used. So let's just say this is phi, let's look at the homework so that we can be coherent. So I, J represent point 0 and 10, and then regularly designed. So in this design, this is called phi 11. This is called phi 21. Phi 3. Oh, sorry, because our index should be shifted in MATLAB. Do you follow me? One means 0 in MATLAB, right? We don't have 0 index in MATLAB. So one means, so in Maple or some other language, this means P00, and this means P11, and so, right? Because of this reason, you should be careful here. What I meant here was general thing, but in MATLAB, this should be 6 and 7, right? In MATLAB. But in other languages, allowing 0 index is okay, right? So it's for MATLAB. In any case, we have this kind of thing. Phi 1, 2, phi 1, 3, and then phi 1, 4. Right? Phi 2, 2, phi 2, 3, phi 2, 4, then phi 3, 2, phi 3, 4. Right? What is wrong? This is not 3, 4. If you have a question, ask me. So I'm using MATLAB standard because over 90% of students use MATLAB. So I decided to use MATLAB design. So this is the idea. Then next thing is, of course, we design this way, but it is not the only way. If you don't like, in fact, in the past, I assigned this with this kind of regular triangle nose. So in fact, I assigned this kind of thing too in the past. And let me briefly go to the example part. I cannot find it. Strange. Is this the one? This is not the one. So let's not worry about it. In fact, I assigned these kind of things before. And it's possible to design anyway. But we are focusing on our restriction. So assume that this is, then it's time to really implement the function. So first thing first. At phi 2, 2, at phi 2, 2, we have surrounding triangles, right? So let's look at east side. East side has phi 3, 2, right? And then northeast side has phi 3, 3. And then north side has phi 2, 3. And then west side has phi 1, 2. And then phi 1, 1. And then phi 2, 1. Thank you. So this is the case, right? So we should have, so this is what I did. So I always use this orientation. I always check the right hand side, right? And then use counterclockwise direction, right? Usually theta angle moves this in polar coordinates, right? So like polar coordinates, we go to east, right? So we always number the point this way. First node is the center, right? And then second node is always this one. And then third node, so we always follow this direction. So we follow uniform design. So this is my first triangle. And similarly, so first triangle is this one in this direction, right? In this direction. And the second triangle is this one, right? Always counterclockwise direction. So this is, I will write the number. This is first node, second one, third one. First one, second one, third one. So we are considering 6 of these things. Do you follow me? We are considering 6 of these. So we consider the first triangle, 1, 2, 3. And then 1, 2, 3. And then 1, 2, 3. So you may sketch these things on your own if you want. 1, 2, 3, right? In this direction. In this direction, right? And then 1, 2, 3. And then 1, 2, 3 in this direction. And then 1, 2, 3. So always use this kind of orientation, right? Or direction. This way you can use the formula that I provided. You have the formula that I provide. Of course, we'll return back to that later, next time, because we don't need, we need something. We'll return back. In any case, this is the idea. Any questions up to this point? So, at each node, we need to consider 6 triangles in our design. But in general, what you do is this one. In general, we have randomly chosen nodes. Then, for instance, from each point, we rotate and then find all the closest nodes, right? All the closest nodes. And then, instead of considering 6 triangles, we may need to consider, like, for instance, 10 triangles or 12 triangles, right? Following these things, we check all the surrounding nodes. But because it's too tough, making it general is too tough, I just made it very uniform, right? So east, right? And then northeast, and then north, and then west, and then southwest, and then south, right? So there are 6 things you need to consider. So you can either make this thing or automate it for generalization in the future. So if you don't have a question, then I will let you know the next piece of the puzzle. So ask question. Yes?
The order that you're creating the triangles in the grid that you established there, I'm not following whether or not we need to establish those triangles within the grid in a particular order, or are we just establishing those different triangles in a particular, I'm not.
So I will be very slow. So let's look at it. So we have a situation like this, and then we are finding surrounding nodes of a given point, right? So we are considering this point, right? Then we use usual polar coordinate system idea. So we go horizontal, right? And then go up, right? Go up. Then we can find this triangle. This is the first triangle that we found. And then afterwards, we find the second triangle, but always this is the starting point. 1, 2, 3. We need 3 points, right? So 1, 2, 3. So we covered this triangle, right? And then 1, 2, 3. So we covered this triangle. And then 1, 2, 3. So we follow these things to cover all the surrounding triangles. Then the next thing is just using the formula to determine the function involved, right? Because here it has 1, right? Here it has 1. Height is 1. Here it has 0. You saw these things before, right? Here it has 1, and then it has 0. Then how can we determine values inside this triangle? Do you know what I mean? I will write a triangle very big and then show you the point. I will make it intentionally very general. So it's not the triangle of ours, but at least assume that this is the center point 1, right? This is the first node having height 1. Then this has height 0, 0, right? This has height 1 and then 0. This is second node and this is the third node. So circled number means the position of the node, right? First node and second node and the third node, right? So we have this thing and then 1, 0, 0. Then can you determine this formula? Last time I showed you the actual calculation, right? So I will return back to the formula to show you what you need to do. So once it's inside the triangle, you can use if condition, right? You can use if condition. In other words, assume that xy is given. Assume that xy is given, right? You want to calculate p, I, j, xy, right? So once assume that xy is given, then you should check whether this xy is inside this triangle or not, right? So assume that it's inside the triangle. Then you can now use this formula. You can now use this formula to determine the value of the function at the given point, right? At the given arbitrary xy point. Do you follow me or not? Yes.
I'm not sure I understand why we're trying to determine whether or not a point xy is the point xy that we're trying to determine whether or not it's within the triangle. What you really mean to say is whether or not that point xy is on the surface of the plane of the triangle. Is that correct?
No. We are seeing the domain, right? Everything is in the domain.
Right.
So everything is in the domain, and then we are calculating height, right? Height is number, but at least we have xy position, then it's in the domain. Then we should check whether this point is included inside the triangle or not. If it is not inside this triangle, formula can change. In other words, it could be completely outside the neighbor or inside some different neighbor, different triangle. In other words, we are checking whether the point is in specific triangle or not. If it's in specific triangle, then we can determine the height. But if it's not inside the specific triangle, then we should check the other triangle and some other triangles, right? Another triangle, another triangle, another. So this is the formula that you should use, right? It's very straightforward, very straightforward. In other words, once xy is plugged in, right? Xy is plugged in with the triangle information, then you can easily check whether the point is inside the triangle or not. And then you can even calculate the value at the point. So I will pause, and then you can browse, and then you can check whether you can really implement this part or not. I will be very slow. This time is for you to really program. I don't want to just ask you to program this completely on your own. Someone already did it, but I want you to do these things. take a look. We have a domain, right? Now arbitrary point is given, right? Then we should check whether this point is in the neighborhood of the given node, right? So we are checking the east side node, right? And then we are checking the northeast side node, and so we are checking 6 triangles, right, to check whether this point is around the neighborhood or not. If it's not inside this 6 neighborhood, then the value is 0, right? Because only the neighborhood may have non-zero number. If it is outside this neighborhood, then it should be 0. So this is the idea. And if you have a question, ask about this idea itself. So we are checking the value of this function ij position, right? Ij generic position here. And then we have a given point. Then we should check this point is inside the neighborhood or not. If it's not inside, it's automatically 0. But if it's inside something, then we should check in what triangle. There are 6 possible triangles, right? East side triangle, northwest, and northeast, and so on, right? There are 6 possible triangles that contains that position. So we are checking, because initially we don't know whether the position is inside the triangle or not. We just check one at a time. So we check east triangle. If it's in the east triangle, then we can calculate value using the formula. If it's not in the east side triangle, then we check the northeast side of the triangle. And then if it's inside the northeast side, then we can calculate the value using this information. Of course, what has changed is the information of the node, right? Node 1, node 2, node 3 rotates, right? Node 1, node 2, node 3, and then node 1, node 2, node. So these things change. So we check these 6 triangles, and if the point is not inside these 6 triangles, then 0, because it's outside. So I will, instead of just dry explanation, I will return back and show you one more time. Basis function of 2 by 2, I will subdivide it, and then use 1, 1. So this is what I meant. So let's look at it. So we have 6 sides, right? So east side triangle, northeast, and then north side triangle, west side, southwest side, and then south side triangles. So once position is given, then we should check whether it's this triangle. And then if it's not, then we check whether it's this triangle, and so on. And so we check all 6 things. And then assume that the point is not in any case like here, then it's automatically 0, right? It's 0 height. So I'm showing you the idea and then explaining the steps. Assume that it's inside the first triangle, right? East side triangle. Then what is the value? In other words, I know that it's inside this triangle. Then how can I know this value? How can I know this height? How can I know this height, right? This kind of height. Use this formula. So you implement this part. Do you want to see this code? Do you want to see? It's not very difficult, as you can see. It's very straightforward. I may have this thing here, so how did I name it? I think it's V3. I named it V3. It's very simple like this. Very simple code, right? Yes?
So the X1, X2, X3, that's like the first node, the second node, the third node. And each time you go to a new triangle, the order of those nodes
Always,
changes.
order is always center one is always has one. And then the side has 2, and then the remainder has
And
3.
the equation, each time you move to
Right,
the triangle,
right,
the
right.
node order.
Right, node order changes. So that is the reason why triangle information is given in this input form, right? In this input form, 0, 0, 1, 0, 0, the input form. And then we can easily calculate the A value, B value, C value given here. A value, B value, C value given here. And then using this, you can calculate the value. And then I didn't want to write the same denominator each time, so I just calculate A numerator part, B numerator part, and C numerator part, and then divide D later, right? Divide by D later. I just gave you 2 part, and then you can check. Of course, to make it robust enough, I always check whether the triangle is legitimate triangle or not. If determinant of these 3 points is 0, then it's not a triangle. I always check this kind of thing. So I showed you even the value calculation. Are these too difficult? Triangle checking or value calculation, is this difficult? So this combination of these small things make a nice program. When I worked to develop Pro-E CAD product, the file number was 20,000 files. And in each file, there are sometimes 40 functions like these. Then by combination of these things, it does a lot of work. In any case, if you have a question, ask me. If you don't, then I will go to the next system. So mostly it was written in C code, and some portion was written in Fortran. So we should link and combine and compile and then do stuffs. And for instance, team A may not know what team B does. Completely separate functions are developed. In any case, I showed you the second part, and then I explained this. In other words, all we need to do is given xy, then check whether it's in these 6 triangles or not. In fact, we are using just east, north, or something, but in actual programming, you can use neighbor idea, and then it's not just east. We can use horizontal node first, and then go through, and then check the closest to the center, and then create the linkage information. It could be varying size. In other words, some triangle may have like 12 linked nodes, right? Some triangle may have only 4 linked nodes. Any questions up to this point? Then, before taking a break, let's not be very serious. Let's just consider lighter topic. That is, what if it hits corners or sides? Is it a bad break or a lucky break? What do you think? Bad or lucky? If it hits the sides or corner, it's, in other words, if we need to consider this kind of position, then is it a bad break or a lucky break? It's a lucky break. Why? Because you have less number of triangles to consider. Instead of 6 triangles, assume that it hits this part. Then how many triangles are involved? In your design, how many triangles are involved? Only 3 triangles are involved. Right? So you are lucky. You have lucky break, right? 3 triangles are involved. If it hits corner, even luckier. Assume that you are considering basis function at this point, then how many triangles are involved? Do you doubt it? I will show you. So first one is the center, and the second one, then as you can see, right? Only thing you need to consider is east side the triangle and northeast side. That's it. Then how to design might be mentioned later, not now, but at least this kind of thing. In other words, yes?
So what does the bottom right basis function look like?
Bottom right. So first, second, third, fourth one you want to see, right? So I will show you this one more time, and the fourth thing will be shown.
So that's only one triangle.
Luckiest, right? Luckiest. Very nice, right? And then top one, right? luckiest case. In other words, you don't even have east, right? So in your program, you can check whether east side has real point or not, and then you can do anything you want to do. Check using if conditions, or I didn't use if, I used something else. But it's up to you to design that part. In other words, your routine may check no matter what, east, northeast, and so on, right? But instead of doing that, your routine can be smart enough to just detect and then don't go that kind of thing, and then just do this, right? So let's look at the shape. So this is the phi 4, right? Phi 1, phi 2, phi 3, phi 4, having 1 here. If you want to see more, ask me. If you don't, then let's take a break, and then I will just present the basis functions one more time so that you can get the better idea. And let's resume at 3. And you can ask questions. Excuse me?
Did you do the top view on that?
Top view. Can I stop it? Each time when it creates, do you know any command? Then you can add a command. Then you can see it. So I should try hard to show you the top view. Oh, you have a luck. Yeah.
Like I'm assuming it has a linear
Yeah.
basis function.
Yeah.
So if we use like sine, have like a weird shape program.
Yeah. Because we didn't design completely regular. In other words, in fact, in the past I used regular triangle. Then isosceles, right? Then it has nice thing, right? But we have a little bit biased triangle shape. But this is easier to determine node positions, right? Node position. But once you program these things nice enough, then you can handle almost anything. Instead of just east, you can just check the neighborhood and then find all the linked nodes, right? All the linked nodes, and then do the same thing, essentially. But that's too much. I don't want to make a fully general program. I don't want to ask you to do these things, but I want you to just program this at least one time. So you may take a break or look at and ask questions, or personally comment and change the command or do anything. Basis functions having 1 here, having 1 here, having 1 here, having 1 here, and so on. So these are the shapes that they submitted. Having 1 at this point, right? Having 1 at this point. And then having 1 at this point. I guess this one has this shape. I'm just showing you many possible cases. So instead of our style, it is symmetric style, right? Our style is not symmetric. But I asked before about the symmetric style, and the students submit these kind of shapes. Do you completely follow me? So depending on triangles, you may have this kind of basis functions, right? Having 1 at this node and surrounding node 0. Having 1 at this node and then surrounding node 0. And then having 1 at this point and then surrounding the 0 and so on. But Why did I show you these things? Because of this reason. To program these things, they just use their typing skills instead of brain. Take a look. A lot of if conditions. So everything is if, everything. Then assume that I increase the size to like 10 by 10. Can you imagine? So this is the one that you should avoid. That's the reason why I provided you with inside the triangle determination function, right? That is inside triangle. Instead of writing these many lines, you can just write one simple function checking 3 points. And then the given point. I cannot imagine how this person can expand these things above like 2 by 2 case. In other words, if I asked 10 by 10, I might receive like 2 mega file, right? In any case, you should try to avoid this kind of situation, right? Take a look. For instance, 4 if conditions, and then even these conditions are not easy to handle. So try to avoid these things in your coding. In any case, I mentioned about the basis functions, and in my opinion, all of you completely understand the ideas like this, and I'm waiting for any questions, and if you have a difficulty, ask me. Because
I have a rather silly question.
mm-hmm.
So, for example, MATLAB, when it plots these anyways, if we just give it a matrix of points, it connects it by a bunch of triangles already. So why do we do all this extra work?
So if we have small mesh size, then as you can see, the actual position might have some height, and it may not be determined by just nose point, right? Nose heights. In other words, it is in between. Then how can?
Wouldn't it just be practical to pick our mesh size to be the same as our grid size?
Oh, that is a good idea. That is a good.
Then we don't have to.
Yeah, that is a good idea. So that's the reason why I had 2 versions: fast version and then slow version. Fast version, in fact, abolished these things and then.
All right.
Good question. Oh, in addition, I found that
We have to do the slow version.
you don't have to worry about the homework 8 when you do FEM. Do you know what I mean? Homework 8 asks about basis functions. That's it. Separate issue. Homework final exam, let's look at the final exam. It didn't say about, you got the clue already. So look at the final exam. Did I ask anything about the basis function presentation or graphic? Nothing, right? In other words, I only asked you to solve this problem using 200 triangles. In other words, you don't even have to worry about any presentation of. But if you are curious about basis functions, you may do it, or you don't have to do it, because I did it, you saw it. You can review these things, archived file, right? In any case, I will mention about one more thing, because this is not very theoretical part, but people spent a lot of hours, literally, to figure out the animation. So this is my animation. It isn't the best. You may know better way, but this is my animation. So what I did was this one. I divide x direction and y direction by appropriate number of intervals, right? 101 nodes, right? In x direction and y direction. And then the value of phi, I used phi value, but it could be any value, right? Any value. So let's say just value or height, right? Height value, right? So then for each entry, I calculated the value, and then I stored this value inside the array, right? The matching number of array, right? 101, 101, and then height at each point is stored. So there are three things: x REN, y REN, and then the height information. Then just surf this thing using x REN, RN, and then height value, right? Height value. But strange thing is this: if I used user matrix, it somehow reverses the axis. I just attached the transpose. Then it sketches it. Then by using loops, we can do the animation. Without loop, like this, without loop, it is just one surface sketching. It is just one surface sketching. So I will show you. Without loop, it might be hidden behind some. So you might have better idea, but I'm lazy learning MATLAB, so I just use whatever works. What is the problem with this, Steve? Oh, there is error here, right? What do you think is the error? Key. So this is the surface that I can sketch, right? So it's surface. It's surface, right? Surface like this that I sketched. Surface sketch. And then now we sketch these things many times to create animation. So I will now add this thing, and then add this thing to animate. About pause is about point like 3. And then I will change the functions. I will use t, right? T times. Then save it. And then let's run it. Do you follow me? So this becomes an animation. Let's make it more dramatic. It's not a good idea, around 15. I just made a function. So it looks like an animation, right? So if you need animation in MATLAB, use these things. Maple has completely different idea of animating stuff. So any questions about animation? This is my method. You may have way better method. I only know this method. That's the reason I use this. But if you have better method, use your idea. So please look at the animation part and ask questions. If we remove this thing, if we remove this thing or make it very small, then it will look like real animation, right? I didn't have time to enlarge it. Right. So let's use oscillating function instead of this function, right? Thank you. So let's run it. It is really animating. So sometimes you expect something and you get the other thing. So I need to amplify this kind of behavior, right? This is how can we animate it reasonably? Do you have any idea? Any idea?
Increase your pause.
Or we can slow down, right? You can slow down, right? A little bit better. So it looks like real animation, but in fact, we are sketching surface many, many times. So as far as animation is concerned, I gave the file for two-dimensional animation. I gave the file for three-dimensional animation. For Maple user, I gave an example. So in fact, I gave the necessary ingredients, but if you still have a question about animation, ask. Then the next thing is really making basis functions. This is the end of today's lecture. So really making the basis function from scratch. In fact, all we do is just organizing what we developed. So I will visualize it, because if I just explain these things dry, then some of you may wonder what is going on. So I just break up this way intentionally, 2 here, 4 here, and then showing you the idea. So this is the first one you want to find, right? And then phi 2, 1, and so, right? So for I want to use index k and then index L or anything, but I will use this way. For k running from 1 to 3. And then for L running from 1 to 5. This is not or Maple code, just explaining the idea using pseudocode, right? Then phi oh, I'm giving you the I should have given you the input up. So I should have given you the input first. Input coming in should be what is our goal? Our goal is this one. Phi I j x y, right? These are input we need. And we assume that we know the m value, right? We know this. We assume that we don't have to input m value or n value. We don't have to input these things. We assume that these are all known. But if these are not known in your program, you should add more input value. So we should give I index, right? And then j index, right? We should input these things, right? And then x position, and then y position. Do you follow me? So these are all coming in. Then what should you do? You should return one value. That's all you need to do, right? Do you know what I mean? Check it. I position here, j position here. So we have a position. Then this ij is also input because ij can change it. But at the same time, the value xy also changes. So there are, in fact, 4 numbers, I, j, x, y, 4 numbers plugged in. Then with these things, computer should calculate the height. Sometimes 1, sometimes 0, sometimes 1/2, sometimes 1/3. We don't know. So our program should do this. If you have a question, ask. Assuming that M and N are already known to the program. But if you want to make it general, then you can input these values to, in addition to these things, you may add like M and N or more things, right? You may add more things if you want, right? This is not necessary, but if you want, you can do this in your program. Do you follow me? Then let's continue. Then, first of all, we should find the anchor position, center position, right? Anchor position. So what is the anchor position or center position? So do you like center or anchor? Center or anchor? Center position is the point having height 1, right? Center position is the point having 1, height 1, right? Then it depends on M and N, right? It depends on M and N. For instance, what is phi 2, 2? What is phi 2, 2? Phi 2, 2 is the one having 1 here, and then 0, 0, 0 at surrounding point, right? This is phi 2, 2. So this center position depends on M and N and IJ, right? So 4 numbers are involved in the center determination. So for instance, center position should be, so this is just designing part. The center position should be M, and then N, and then I minus 1, and then J minus 1 is the center position in this case. If you design differently, these change. So it's not a general one, but for a specific one. So now center is determined. Then east is very easy to determine, north is very easy to determine, so right? So let's determine. So I will show you my design. This is the first triangle I want to use, right? So center here, and then east, and then northeast, right? So I design this way. In other words, I only need to store the information of east, or just 0.1, 0.2, 0.3, 0.4, 0.5, 6, right? Then we can make a circle, right? So I store P1 position, and then P1 position is this center in vector notation or coordinate system notation, center position plus M over 1, right? This is the east. Do you follow me? If you don't, ask me. Center position and then advance appropriate number of units. And then point 2 is this point 1 going north, right? Going north, right? Point 1 going north. Going north. And then please fill in these blanks. By practicing these things, you get the idea. You can use center, right? If you don't like it, if you don't think it's uniform, you can use the center here. So I will intentionally change. It's possible to use this thing, but to be uniform, you can make these things from the center, right? Center plus this thing, right? Then please determine these things, P6. And then if you have difficulties or questions, ask. Difficulties?
I guess
For instance, you may pick ij inside this boundary. What I and j do you want to pick? 1, 1. Then 1 minus 1, 1 minus 1, 0, 0, right? So 0 is the center position in coordinates. In other words, this is actual domain. This is the actual xy coordinate system, right? This is actual xy coordinate system between these things, right? Our design uses ij. So you should replace x by ij and then y by ij, right? In other words, center position should be the actual position, while ij are just indices. And then I matched it. Is it clear enough or not? In other words, give me ij, like you said, 0, 1, 1, right? Then what is the center? What is the center? 0, 0. Give me other numbers. 2, 3, right? 2, 3. Then what is the center?
I understand putting the number.
Right. So,
Okay.
yeah. You now get it? Great. So let's not worry about this 4 part now. So let's just comment this out and then just writing down stuff. And then did you get it? The final point should be what? Center minus the last point is here, right? So assume that we are using this thing. The last point is 0 and 1 over n, right? This is the last point. For technical reason, what should we do? For technical reason, I want to make a loop. That means, what is a good idea? Introduction of something is a good idea. What is it? P7, right? For technical reason, it's good to add P7. P7 is nothing but P1, right? P7 is nothing but P1. So we now have the center and surrounding points. All we need to do is making a loop to do the calculation, right? That's all we need to do after this. So I will pause and then you can check the design. In other words, we have the given point, right? Having height 1, and then 0, 0, 0, 0. Then we have height 1, and then 0, 0. Then how can we determine the center and northeast and so on, right? East, northeast, east.
If you use that loop, don't you have to go back and pick up the corners, or are you going to miss the corners when you use this scheme?
I see. You mean if we have the center at this kind of point, right? You meant the center at this kind of point, right?
No. The center where you have it there, but if you divide those rectangles into triangles, aren't you going to miss the corners?
Yeah, these corners are missed. These corners are not.
Okay. So you eventually have to go back.
Right. So I will show you the loop. It loops this way. First, second, third, fourth, fifth, and then sixth, and then right, return back. That's called sevenths. Any other questions? Then now the loop part comes in. There are 6 triangles we need to consider, right? So for triangle running from first one through the sixth one, right? From the first one through the sixth one, vertex 1 is center. Vertex 2 is P triangle 1, right? And then vertex 3 is P triangle plus 1, triangle position 1, right? This is it. So you always use vertex 1 as center, right? So vertex 1 is always the center, right? Center is the vertex 1. And then surrounding triangles, right? P2, P3, right? P1, P2 forms complete triangle. But now this can be the next one, and then the next one, and so on. So we rotate 6 triangles this way. And then vertices are all determined. And if you have difficulties or questions, ask me. The next thing is this. If xy position is inside the triangle formed by this vertex 1, vertex 2, 3 thing, right? If this is contained in this thing, then what should we do? We use the formula that I provide, right? We calculate the value of xy with the given triangle information, right? Vertex information, right? So anything, this is not the actual program, just giving you the idea, right? Calculate the value of xy with the triangle information v, vertex information, right? Three-point information with this thing goes in. Then I showed you the code before. I will re-show you. Yes?
So we're just going to allow the point xy to range throughout the entire domain.
Right, right. Any xy. So as I mentioned, all these things are free, right? All these things are free. I is free, j is free, and then xy, all these are free. Then with these things given, we create this thing to calculate the value. In other words, once these things are in, you should return just one value. That is the height. Once you create this thing, you plot it. That's the way I did. Yes?
What is the difference between the P points and the vector points that we just calculated?
P point is just many different positions. These via triangle vertices, vertices. P point are general points, like 7 general points.
But they're, the way we wrote it here, they are also the vertexes of each one of the triangles too, right? Each
That's true. That's true. That's true. Right.
So I'm not sure I understand why we're calculating a set of V's as well as the P's. I'm not sure I'm seeing what the difference is.
Because assume that we have 6 P's, P numbers, then there are how many triangles total? 6 triangles, right? Then how can you form one triangle out of P? There are 6 different triangles. Then how can you form? Using center, vertex 1, vertex. That means one triangle, right? That is the reason why vertex variable is used.
So do you know the difference between where on the triangle the height is 1 versus where the triangle height is 0?
Right. Always 1 is the center. Center has height 1. And all others have 0. This is the design idea. In other words, always center,
Center is always
vertex 1, and the vertex 1 has 1 always.
So the vertex is only 1. We're only calculating 1 out of 9 point. 1 out of 9 of the points is the vertex. Can we scroll back down to the V there again for some reason?
So for triangle by triangle, because once we have a triangle, then we have 3 vertices involved, right? But always center vertex is involved no matter what. So center vertex is the first vertex no matter what. And then we rotate it from the first triangle, you mean east side triangle, and then northeast side triangle, and then north side triangle, and so on.
I think I'll get it once
And then now I showed you the calculation of V, right? So point and triangle is given. Then calculating the value isn't difficult. But this is the secret. Here, if somehow these 3 points do not form a triangle, then I return 0 value, right? So I made it robust. In other words, bad things are coming in, then it just returns 0. In other words, it doesn't hurt very much because 0 doesn't affect very much. But this, if we exclude this part, it's as easy as just 3-line program, right? A 4-line program. How did I get these things? From the formula that I provided. So as you can see, here the formula is used, right? This formula is used. So use this thing, right? Once we have x and y input, then we can create a plus bx plus cy plane, right? Equation of the plane, right? Equation of the plane. Then, we're using the equation of the plane, we can determine any value at any point, right? The value at any point, right? The value at any point inside this triangle domain. So these are the steps. In other words, once you create it, then it will run and then traverse all the points and then calculate. And I'll show you so I will call this value at 3 points, right? Value of this. So I called V3, but V3 isn't a very great name. But in any case, let's return back to the node. And then here, I said, I used value 3, right? But value 3 isn't a good name. So height might be better name, right? Height might be better name. So height at point with triangle is calculated, right? That's the one that we need to return, right? If this height is not 0, then return height. This is the result that we obtain, right? This is it. So this is the Pij function. So essentially, this is it. I don't want to cover any more things to confuse you, but I will explain fully about any aspect, any difficulties aspect. So this is it. Take a look. I will go through one more time. We have the function value that we want to calculate, right? Ij coming in, right? Ij coming in, and then xy, right? Ij is random. In other words, you may pick this point or this point. So Ij is random, right? And then you may pick xy position. So these 4 numbers are coming in. These 4 numbers are coming in as input, right? And then we may divide by m and n, right? Then all we need to do is checking the ij position in coordinate. So this ij are integers, but we cannot use integers. So we should calculate xy, right? These are xy. So xy position, not this xy, but the coordinate of the center, right? Coordinate of the center. So center is calculated. After calculating the center, we fill in these 6 points, and then we make a cycle by adding 1. This is a technique. This is a technique. If you don't use this thing, you should add a lot of ifs. But if you add this thing, just you can rely on one cycle. And then, after creating this cycle, you just go through each triangle. There are 6 possible triangles. So first triangle, second triangle, third triangle, and so on. And then calculate whether it gives any reasonable value or not. Any reasonable value or not. So how do we determine vertex? Vertex 1 is always center, and then surrounding points, right? Then this is. So as you can see, this simple program does it. So please compare the one that you saw and this one. as I mentioned before, the one you saw cannot even do these things at other points. So let's go back to the example. So this is an example, and as you can see, if you program this way and then assume that there are 2,000 triangles, then to check individual triangle, we should add many, many if conditions, right? So assume that there are 2,000 basis functions. Then how can you do it? Only typing technique, or you can use some kind of program to type these things. But with the correct design, you don't even have to worry about these things. About these lines are enough to completely program 3 functions that I mentioned. Checking whether point is inside the triangle or not, calculating the value using this formula, and then finally, using this formula, right? Using this formula. And then finally, returning the value, height value, by taking these input values. So this is the thing that I did and then presented.
So what about the basis functions on the boundary?
Basis functions on the boundary. That's the one that I want to explain very soon.
Find the 6 points.
Yeah, that's the one that I want to explain very soon. But if you are completely satisfied with these things, then I will mention about anomaly handling. It's not very difficult.
So this is only the interior.
Right, interior. But just by adding one thing, it will handle anomalies. So, do you remember that I used non-triangle checking in R determination? Do you remember? I mean, inside the triangle checking determination, I used 0 if it's not a triangle. In other words, if it doesn't have this kind of thing, in other words, here you can add this kind of thing. If so, there are 4 possible sides, right? There are 4 possible sides: east, north, west, south side, right? So we can just make insert this on after center. So at the center, we check 4 sides, and then check whether this goes out of domain or not. You follow me? If it goes out of domain, then what should we do? We just, so if condition is plugged in, and here, if these kind of things happen anywhere, right, then we can add just center. Assume that P1 is outside the boundary, then this is stored. Then it is not an actual triangle. So center, and the next point is also center. Then it's not a triangle. There are 3 points involved, right? But we populate the one with center if it is boundary. This way you can break it and then violate the condition and then return 0. But I will explain the idea very soon once you get the idea. In other words, we are checking whether it's east, whether the east point is outside the boundary or anything of these things are outside the boundary, right? And then do it. So this kind of routine can be added. But I just explained the idea, and I will provide this thing very soon. But knowing this interior or 6 edge condition is very important. After knowing this 6 vertices condition, I will add that kind of checking routine. In other words, these things will change a little bit. These things will change a little bit to handle this kind. In other words, if the point is outside, then you just store center. Then center, center. There are 3 vertices, right? 3, center, center, and some vertex, then it's not a triangle. Then automatically, 0 is returned. In other words, later you just add this kind of thing. You don't even have to worry about this thing. This thing runs no matter what. And then you say, oh, it is already checked here. You don't even have to worry about it. It's already checked here. So I will pause and then add that part very soon. But if you still have a question about anything, ask. At least interior question. Because this is not a full code, if you just type these things and then translate, yours may not work. So you should do some work to check whether individual steps are logically working or not. And then, in fact, practically working on. So for technical reason, it's good to assume that height is 0, right? Assume that height is 0. And then, if height changes, right, then we return heights. But if nothing happens after this routine, right, after this routine, if nothing happens, then automatically 0 value that you stored is returned. That kind of thing is technique. But let's not worry about the technique too much and look at the idea of this part. Then I will write a version and then I will modify this part, right? So I will modify this part to handle corners, right? With this pattern, it doesn't have any limitation, right? It doesn't have any limitation. In fact, frankly speaking, this basis function works because if it is outside the boundary, the domain xy value doesn't even go out. Do you know what I mean? So in fact, we don't have to touch it. But if you want to make it robust, then you may add. So let's not worry about corner points because what I mentioned is this one. We may create something bigger than necessary. In other words, initially, we wanted to design something, some basis function inside this domain. But our routine expands these things to the corner, right? And then somehow it defines like this. Right? It defines like this. Because of corner stuff thing, right? In other words, basis function is defined more than enough. But our input value is automatically inside this, right? Our input value is automatically inside this. In other words, even if something was calculated here and some triangle is created here, it doesn't matter. I don't want you to make it too difficult. So let's not add these things here. But as I mentioned, when I did it, I in fact calculate that kind of thing. In fact, this kind of boundary condition should be considered in next session. Because why should we worry about this kind of thing? We are integrating over something. If we allow outside the domain, our integral value at boundary will change. That's the reason why, in fact, I add this thing in my code. But for basis function, let's not make it too hard. For the integration, we should consider boundary because it doesn't have boundary. So if you integrate there are only one triangle to consider at this corner, right? Or at this corner, we should worry about only 2 triangles, not 6 triangles. Because if we add this, the integral value may change. Do you get the point? But as far as, because I, in fact, solved FEM first and then extract these things to basis, that's the reason why I was a little bit confused between basis and the FEM. But let's not worry about boundary as far as this is concerned, right? So our basis function covers even these things, right? Our basis function covers even these things. But later, when you do add integration, then because later we should solve FEM. That means we need to calculate these kind of things, right? We need to calculate these kind. Then we should integrate triangle by triangle. So interior, we should worry about 6 triangles, right? But exterior or corner, sometimes 2 triangles, sometimes 1 triangle we should worry about. In other words, if we just blindly apply 6 triangle formula, it may calculate these values and then give you wrong information. Then we should chop these kind of things using some technique that I will provide. Let's not worry about that. So this is the end of today's lecture, but I will answer questions from now. And if you completely understand everything up to this point, you may leave the room. But if you have still questions, ask. Ask. This time is for you. In other words, after this, you should go home and then spend about 2 or 3 hours to complete these things. And then really, if you are interested, you may sketch it. Because you have a function, right? Function, then you create x and then y mesh, and then just call this function, then you create the thing that I did. But you don't have to send the presentation part. Just send the function. That's all I want. But when you send the function, send the required functions such as triangle checking or value calculating function. If you don't send, then yours will not run. So please send those things. But from this point on, ask questions about the design idea or the functions that I explained. If you complete this, you may return next time. Try then. That time, I will completely connect these things with FEM ID and then solve the problem. No problem. Homework gate is just this thing, just calculating the value. In other words, I, j, x, y is given, then give me one number. That's all I want. That's all I want. I is, for instance, 6. In other words, p, 5, 6, and then some point. Then what is the value? That's all I want.
Basis function, like a function that generates the basis.
Right. Yeah, you are creating basis functions, or the one that I explained here. In other words, this homework is just one thing here, because when I assigned this in the past, people just did all possible things to create this kind of thing, right? But now, I don't want you to make that kind of thing. I want you to make this kind of thing. So this is homework A.
Does it ever really matter what our like delta x or delta y is?
Doesn't matter. For instance, take a look. If you have this smaller data, for instance, if you want to use this, then you can use 100 here, right? And then 100. Then there are total 10,000 rectangles, meaning 20,000 triangles, right? So you can just use a different MNN. That changes delta. But did I rely on specific MNN here or not? I didn't rely on any specific MNN. You just did this. So from this point on, you read the note and ask questions. If you completely understand it, you don't have to be here. So please browse the notes and check whether you can really program these things or not. As I mentioned before, this course is really programming something and then present something like basis function. I'm describing just this thing. Yeah. Yeah, so it has 1 at the node, and the surrounding point is 0, and then, yeah, those things.
Can you go over just a little bit of how you're actually sketching that?
Oh, you mean animation part?
We find all the heights
Right?
in each triangular point.
Right?
But then how do we assemble it into one picture?
You create mesh like this, right? You create mesh like this, right? And then you calculate the value at each point using phi, ij, and then kr or kc or xy, right? Xy position, right? Xy position, right? Xy is the input. Then with that input, you did calculate each value. Do you know what I mean? And then this is the one basis function part. So take a look. T is for only animation, so this T is not necessary. Oh, just a moment. XY represent, sorry, XY has no connection with this thing. So X ran KR, right? And then Y ran KC, something like this, right? Or vice versa. Yeah, I was, yeah, because XY cannot be directly used to sketch something. So we calculate at mesh point, right? We calculate the height at mesh points.
So you have a matrix called H-val, that's a two-dimensional array there.
Right,
You fill with all the height.
right. IJ is given by the problem, right? IJ position.
Right. Determines by
Right, yeah. So I made a loop running through different IJ, right? So as IJ changes, you see the shape like mine. But in this case, I extract the essential part. I use 7, 3, right? In this direction 7, in this direction 3. But let's use different. What ratio do you want to see? I want to use your ratio. How many subuniverse do you want in the x direction? Anything less than 10? 2. And then in the y direction? So in the x direction there are 2, right? In x direction 2. In y direction there are 7. It is traversing interior first, and then it traverses the boundary in the counterclock direction, counterclockwise direction.
Did you see that exercise? One of them was a plane on the floor.
It might have something, but let's see, around there we saw the reason might be some angle, the angle.
The floor will turn here, right?
Yeah.
Like that. You know why?
No. It might have something here, right? Something here, but I do not know. So I will investigate that part. So it should have this kind of shape around here, right? It should have this kind of shape. And then, yeah, something. Yeah, so I might have a bug in my code. Yes. Uh-huh. Uh-huh. Let's go to that part. By the way, I will return back to this part and then check it. 2,7, right? 2,7 will be checked later. So let's go to that condition. We only mentioned about the node area, but assume that there is a triangle here, and then 3 heights are zeros. That means this is 0, right? Inside the whole triangle. In other words,
One of those triangles
of this neighbor, right?
outside.
Right, outside this neighborhood, we have triangles, many triangles, and those things are all 0. Just simple condition, just a 0. Right, all these things are 0. Right. Right. Yes?
So the goal is to plot the linear combination of all of them.
You mean homogate?
Yeah.
No, goal is just one number. I want one number. In other words, I give you, so once you send me the result, what I will do is this one. P, I, J, for instance, I is 2, I is 3, and then J is 7, and then X is 0.11, and then Y is 0.51. Then you should give me one number. That's all I want. That's all you need to do.
Does yours output one number?
Excuse me?
If you hit enter right now, would yours output one number or not? Would yours output height right now if you pressed enter?
I do not know because I create differently. Mine is different
I
from you.
misunderstood your directions and did something entirely different. Yay!
Well, if you were already plotting them, that's pretty good.
Yeah. Well, yeah, I was doing, you were thinking the linear combination, right? That's what it said on there, was that we want to plot it, so I was like,
Yeah, that's all you want. To do it, we implement this thing. And then once this is done, then we can do any linear combination. That's not the one that I want, but only P creation. That's all you need to. Then we can use linear combination that I showed you, right?
I got the linear combination of the P-splines to work, so I think that helped.
Yeah. You're right. So let's return back to that strange thing. When I run this thing, it showed the strange. So let's go to the basis of this thing and then check what is going on. Basis of this thing, 2, 7, 2 and 7. And then, do you remember the position here, right? So it is, there are 2, 7, and then 3 times 8. 20, 24, and then this corner, and then 6 more. I guess 18. 18 had this strange problem. Yeah, so let's examine what happens by debugging it. It's supposed to have 1 here, right? 1 here, and yeah. So I will check what happened there. I will check this part on my own later. Yeah.
The hard does that.
The 1 point test.
Are you going to test more than one point?
I will make one just simple linear combination like that one and then plug it in. Then yours will run and then I will check the shape. That's all I want. That is called quality assurance. You just create phi function. That's all you need. Then I can do all linear combination using your function. Yeah, MATLAB or Maple. In fact, Maple can do way easier than MATLAB. So ask a question. You have only 15 more minutes because once I leave the room, I will rush to home and then prepare, pack the bag, and then the problem is not that kind of thing. You should make presentation. That's the difficult part. Yeah, tomorrow, like I should leave home about 4 a.m. So I should sleep early, get up early, and then go to Denver and then go to Tucson and then present. And then that presentation is the killing part. Saturday, tomorrow. I should present tomorrow. Yeah, it is American Mathematical Society conference in Tucson. So Monday about 11, I arrive in Denver, and I should teach at 1:40. So I should check out and then drive back. On my way, I should grab McDonald's and then come here and then Big Mac or something. So if I cannot make it, I should call, and then the department people may give FCQ. And then while they are doing, I may arrive and wait outside the room, and then.
So you'll be here for your office hour on Monday?
Yeah, at least. But I cannot change my clothes. Please browse the notes and then check whether you completed every component or not. Yes?
So, on the final,
Final exam is too much, right? Don't you think so? You already, you completely understand these things and then want to go to final exam, then others may have a hard time. So, but if you want, I will answer.
I guess just a general question.
Mm-hmm.
The finite element method.
Mm-hmm.
I assume we're using that the A sub k, j, b,
Yeah.
c sub k
Yeah.
equals b sub j
Yeah.
thing to find all that.
Yeah.
The gradient phi functions, those will just be the phis from our triangles.
Yes, gradient. Because we are integrating triangle by triangle, and then this is the part, AKJ part. It is dead. I don't know. What is going on? Computer doesn't work. So I will cover that part. In other words, now we should consider corners. Up to this point, we don't have to worry about corners or sides. But when you integrate, we should check whether the boundary it is outside the boundary or not, right? And then we should integrate inside the domain. So we will do that kind of integral using the formula that I provide. We don't really calculate that kind of integral directly. We use the right here. We have the integral parts. Here, we are using these kind of things.
So we will only have to use those in as far as the boundary conditions go. We're only going to have to worry about those on the
Right. But next time I will let you know the full design of FEM. Because basis function is necessary to do many things, and then this idea can be almost easily translated to FEM calculation. AKJ calculation uses this kind of 6 triangles, so almost minor change. So here you know how to do basis function. Then by just minor change you check the corners, and then you just, instead of using A and B, A numerator, B and C, and right, A numerator, B is to find the plane, you just integrate triangle by triangle. It is in some sense easier because you don't have any input value xy. Just integration doesn't have any input value xy, just integration. Just triangle gives you the integral value. So it's way easier in some sense.
You just have to approach more robust.
Right.
Right.
Right. But the design requires some ideas. So roughly what we need to do next time is from two-dimensional grid, we convert these things to one array, right, or one sequence. This is two-dimensional array, right? Two-dimensional array become one sequence, linear sequence. Then there are tons of different ways of doing it. For instance, you can do this kind of thing, first, second, third, and then tenth, and well, ninth, and then tenth, 11th, and so on, right? Or you can do different way. You can use rows or columns or different schemes. Another idea is this: you go all the way here, and then counterclockwise go up, and then you just like scroll right here. But that kind of thing will be explained next time.
I have a homework. Almost every week, it's all in that lab. Because there's 1 week,
It's like 2 extra minutes.
show.
Thank you.
Well, no, this one's a super easy. One that I've done like 20 times. But I took it, I tore it out, and I keep turning out like, I don't have like a folder for that, because everything's on the computer. So it's just kind of like floating around. Probably should.
You're welcome. Have a nice weekend.
And have fun at the conference there. You'll do good.
I hope. Have a nice weekend.
Should be good by now, right?